Should be okay. Hold on, let me just make it public now. Yeah,
Yeah, did we restart it?
I have started again now, and it's streaming the video.
It works.
Right, it's good. Oh shit, people are trying to get in. Sorry.
The audio from Zoom is coming through on the first scene.
So, sorry, what'd you say, Izzy? Are we recording in Zoom? Yeah. Okay.
Hey everyone, we're gonna get started in a couple of minutes. Hey everyone, thanks for joining. We're going to get started in approximately 1 minute. Hey everyone. All right, let's get started. Hey everyone. All right, on today's agenda for the Lido node operator community, hey everyone, community call number 2. We're going to cover a bunch of different topics, so I'll try to be brief and summarize those things so we can get started with the pack program. We're going to cover a bunch of different topics. The first thing that we're going to cover is the quick update on the block proposer rewards policy, basically what the proposed changes since the first thing that we're going to cover is the quick update and what initiatives the Lido community took to increase community participation. The first thing that we're going to cover is in determining the proposed changes to the Lido community. Secondly, we are going to look at the Goerli Testnet DVT Pilots that we performed with presentation by SSV Network and OBOL Network. Thirdly, we're going to have a brief DVT pilot summary around the Lido community organization manifesto and OBOL Network. Thirdly, we're going to have, and lastly, the Lido protocol around the Lido community and a technical presentation of the Lido staking router. Okay, in terms of the update on the block proposer rewards policy. Sorry, just really quickly, it seems the stream is out of sync. 1 second. Okay. Update on the block proposer rewards policy. So an updated version of the policy has currently been put on for a snapshot vote. The summary of the changes to the policy are setting an expectation of full-scale rollout of PBS Lite via MEV boost for all Lido node operators, defining the responsibilities of node operators in the case of relay misbehavior, failure, or otherwise unexpected non-performant functionality, defining the responsibilities of relay operators towards the Lido protocol and node operators, outlining the possibility for node operators to opt in to using MEV Boost's min-bid functionality in an attempt to decrease possible service degradation. So this would be things like increasing the credible neutrality of the network in the short term. And additionally, the proposal includes the giving basically the relay maintenance committee, which is a multi-sig that has been put together to facilitate the maintenance of the Lido vetted relay lists, the empowerment to help the DAO be a little bit more flexible in the short term in terms of determining which relays will get added or moved between the vetted relay lists. So all of these changes and, well, the proposed changes really have come together after months of work between Lido contributors, node operators, and also independent community members within the ecosystem of the staking on Ethereum space. And it's basically a culmination of a lot of debates, dialogues, and research being done by entities such as Flashbots in terms of determining min-bid application and how it might be used, and also finding the right wording to both give node operators the comfort that they are able to make the operational, legal, and like risk assessment-based decisions that they want to do in order to ensure that they continue to be good stewards of the protocol. And with that, we're going to move over to a brief overview of the testnet pilots that we did with regards to distributed validator technology, and then move on to specific presentations by the two DVT infrastructure providers that helped us with this. Will, if you can take over.
Snizzy. So, hey everyone, I'm Will. I'm a contributor to the node operator management team at Lido. And over the next couple minutes, I'm going to briefly introduce our next topic around Lido and distributed validator technology. So post-merge, one of our top priorities has been to explore how Lido and our node operators could start to participate with DVT at the Lido level. A fundamental part of Lido's strategy to implement permissionless validation actually relies on adopting DVT. DVT will help to reduce the risk of validators underperforming or colluding, and also allow for new untrusted parties to join as node operators. That will help to further decentralize the protocol. I helped coordinate our effort with SSV Network in the first pilot program that started in September, and Sabrina on our team has led the effort with OBOL Network, which started in early October. While there's some key differences between how SSV and OBOL operate, at the Lido level, the process was quite similar for both pilots. We asked for volunteers from the Lido node operators and then separated them into groups. We referred to these groups of node operators as trenchcoat operators, because after they created multi-sigs, which were then registered to the Lido node operator registry, these groups of operators were almost indistinguishable from the normal single organization node operators already in the registry. From there, the separate groups set up and operated distributed validators on Goerli using both protocols. You'll hear more about that from the teams in a few minutes. So you can actually see all these groups of node operators on operators.testnet.fi. And there's links to the validators they're running in the posts about our SSV and OBOL pilots on the Lido blog. While there's still some functionality that both protocols need to implement before they're ready for prime time on mainnet, it's clear that using both OBOL and SSV will be viable for Lido over time. So over the next 20 minutes, you'll hear from both teams about their different implementations and roadmaps going forward. And then you'll hear from Lido and Ethereum team about the staking router, which is core to how Lido will be able to adopt DVT at scale. With all that said, I'll hand things over to Alan to get started from the SSV perspective.
Hi, everyone. Can everyone hear me well and also see my screen? Just making sure.
Yes.
Perfect. Thank you, Will. Thank you, Easy, for inviting me. I'm Alan. I'm one of the founders for SSV Network. SSV Network is a network, permissionless network for DVT. And we were very happy to kind of participate with Lido and start understanding how DVT can be integrated into the Lido protocol. We started out with kind of a simple goal, run 2 separate SSV clusters. Cluster is basically just a bunch of validators, operators, however you want to call them, which coordinate with one another and operate one or many validators. So we had 2 of them. The Lido operators participating were actually already, a lot of them already participated for close to 12 months and even some of them even longer in our existing testnet. So it was fairly easy for them to actually set it up. And the goal was, other than obviously just running those 2 clusters, was really collect initial feedback and collect really kind of a to-do list for how it will look like in the future, what we need to accomplish, what we need to fix, change, and implement in order for Lido to actually integrate. And kind of from early discussions with Easy, Will, and the team, the picture was pretty clear, I think. The idea was, how do you take, on the one hand, whitelisted operators, and on the other hand, permissionless operators? How do you make them work together, specifically in this case, via DVT or SSV? And by working together, we mean that how they can operate validators together. I'll leave obviously all the entire discussion around economics and how do you choose those operators and so on. That's really on the Lido protocol side. But what SSV offers here is something we call zero coordination. The idea is that, or zero manual coordination. The idea here is that you can batch together operators into clusters with a simple contract interaction. And you can do that with any operator you choose. There's no need for any manual coordination to do that, or there's no need for any special setups, trusted or non-trusted beforehand. And so that was kind of the premise. That's how we kind of in our talks understood Lido's direction and how obviously DVT can play along with that. And that was super exciting. And so one of those things was really to understand what SSV can bring to the table. And so we've talked about the idea of a permissionless network. Really like the idea that any operator within Lido, permissionless, whitelisted operator, any type of operator can start running an SSV node and connect to the network. And by doing that, it allows itself to be discoverable and assigned to validators in a very simple way. Also opening up into the ability to participate in a DKG ceremony, and basically creating those endless or limitless clusters of different operators. You can create 10 clusters, you can create 10,000 clusters with various combinations between them. And so we felt very encouraged by kind of the design goals from Lido's side and what we can offer in that regard. And so that was really cool to see. And of course, one of the things we always talked about, and I think not just, by the way, with Easy and Will, but also Konstantin and others, Vasily, is in terms of performance. Because obviously DVT introduces some kind of overhead around staking. So it's very important to kind of measure those stats. And so in terms of statistics, we're seeing, again, very encouraging numbers. What you see here in front of you is really a comparison between the SSV setups on Praetor versus kind of a random sample of Praetor validators. Of course, those numbers really depend on how well you set up your nodes and operators, right? If you set up operators which are not performing enough or not well peered or any of those kind of limitations, you'll see degradation in performance, kind of the same as you see with your traditional validator client. And so in terms of performance, again, the numbers are pretty encouraging. In terms of station rate, we're seeing pretty much the same as Praetor, slightly better, and effectiveness the same, a bit better. And so it's very encouraging to see that even with the added kind of overhead, we're still seeing really great performance. And of course, in mainnet, at least on the effectiveness side, that's going to be higher. Usually Praetor is a bit lower. And so that was also kind of a key thing, I think, to kind of discover both with Lido, but also in general, just in scale and kind of in a running testnet. A few words of where we headed. And so SSV right now is in its second testnet, running testnet, long running testnets. We're preparing just after the holidays for a major version release, which will reset the testnet. That version will basically be the one aligning the client with the SSV spec, SSV mainnet ready spec. So that's going to happen just after the holidays. That will open up basically a bunch of different things, from supporting all of the different duties on the Bitcoin node, Bitcoin chain, to obviously passing all of the spec tests. That's a major milestone. And right after that, we might need or not need, we still don't know, but might need a third testnet, which will also be the release candidate. And right after that, mainnet. So that's kind of where we're heading. Have a set of new contracts coming out. We've managed to reduce gas fees on contracts by 80%, 85%, I think, even. And so there's a lot of different improvements going towards mainnet. And so we're really happy about it. And I think we'll revisit kind of another maybe phase with Lido right after that as well. And so, yeah, that's where we're heading. And the last thing was kind of a shout out towards anyone who's thinking about building anything on SSV. We have both a really nice grants program, but also haven't announced it yet. but will be announced very soon. It's a really pretty significant ecosystem fund for SSV with amazing leaders from the industry. And so again, that goes to show to the kind of the ecosystem approach we're taking, and kind of the soundness of what we're trying to build. And so, yeah, if anyone is interested, please reach out. And that's it. Thank you, guys.
Thank you, Alan. Maybe we can take a quick pause here for any potential questions specific for Alan or SSV or the pilot that we did here. I'm also going to check the YouTube chat to see if there's any questions from there. But of course, if any of the node operators want to chime in here, I know that a lot of you that participated are actually on this call. If there's anything that you want to add or anything specific that you might want to ask SSV. If there aren't, I think there's definitely some questions that I want to ask in terms of the stuff that you're working on for V3. So obviously one of the big kind of features that we're looking forward to being able to use and test is block proposals. Can you tell us a little bit more about how those are going to work in the SSV network infrastructure?
Yeah, so we actually, in our stage or DevNet, we're already doing block proposals and the other duties as well. We kind of waited with it because the core was a bit more important. What happens within the SSV protocol is every duty has a pre-consensus, consensus, and post-consensus phases. Some of the duties don't necessarily have a pre-consensus phase. And so what I mean by that, if you break down the actual block proposal, and so you'll find out that you'll have the phase where you need to sign a rundown and obviously to get and actually build a block. Then you have the block itself, and then you need to, that's the consensus part. You need to actually decide on the block you want to sign. And right after that, you have the post-consensus side where you actually sign the block and broadcast it and so on and so forth. And so that's kind of the layout for all of the different duties. For example, attestations don't really need a pre-consensus phase, sync committee aggregation do, and so on and so forth. And so, yeah, I'm hoping that kind of covers kind of, you know, how block proposals work within SSV.
Thanks for that information. And can you tell us a little bit more in terms of like proposals from the actual like proposal perspective? So is there going to be something where basically all of the different like operators within the SSV group need to coordinate to come up with the same proposal, you know, like some naive form of multi-party computation, or like will it be leader based, or how do you guys envision that working?
Yeah, so it's a leader-based consensus. So what happens is one of the cluster members offers a block to sign. The others receive that proposal. They check it for various things. So, for example, they check that it's obviously not slashable. They check that it's roughly on the head of the beacon chain. And in the future, by the way, it's a bit more complex, but in the future, you can even add MEV related checks. For example, is it at least the kind of 80% of the most profitable block we know, otherwise we reject it, and so on. So you have all of those bunch of tests that every single cluster member runs. Whenever you have 2/3 of the cluster agree to sign something, that is, that it passed all the checks, enough cluster members were online to actually sign it and so on, then they can actually commit to that block. Once they committed and actually decided on that block, then they actually sign it with a beacon chain valid partial signature. Those partial signatures get aggregated and broadcasted by all of the members to the beacon network.
Okay, makes sense. And I think the other like much vaunted feature that we're all really looking forward to, especially from a Lido perspective, as we think about designing systems to enable permissionless participation in the validator sets, is the DKG, the decentralized key generation ceremony. Can you tell us a little bit more about like the work that you guys are doing together with RockX in terms of how you want to envision this working? Yeah.
So our approach to DKG is, we thought that DKG is a tool. It's not, as a tool, it needs to serve kind of the purpose for which it was built. And the purpose, or the kind of the user flow we imagined, was actually very mimicking what we saw in Lido, but also other pools and other use cases, where you have the ability to ad hoc add keys, and you want to do that in a very simple way. And so one of the design goals was to do a zero coordination or zero manual coordination DKG, with the idea that you don't really need any manual intervention, coordination, or any of those kind of fairly complicated setups to start a DKG session, because every SSV node, once we deploy that, every SSV node will be DKG ready. And all of that will be happening on the P2P layer. And so you'll be able to create those DKG ceremonies and actually verify them through your node. And so you can imagine a flow where you have preset clusters that you're expecting to have keys for, and you'll simply create those DKG ceremonies ad hoc, and have the output of those DKG ceremonies will be able to be verified and for various degrees. So the withdrawal credentials you've put, the participating members, and so on and so forth. And then that's it. Just register the validator, make a deposit, and you're good to go. And so we started developing it. The issue we encountered was actually the library we chose, and not mistaken, I think OBOL chose it as well, was a coin-based library for the DK, or the key ceremony. The problem was that Coinbase decided to deprecate it, and so we had to come up with other solutions. So that took us off time a bit, but we're hoping to be pushing hard on that after the holidays. I know you guys are waiting for it. It's something that a lot of people want and need. Yeah, and so yeah, that's pretty much where it is.
Yep, that's great. Thanks for explaining all of that in detail. We're definitely looking forward to it. We definitely plan on doing more pilots with SSV to figure out, how can we increase the categories or types, let's say, of node operators that participate in the DVT-based validators for Lido. And obviously DKG is going to be a super, super important part of that. Thank you.
Yeah. Thanks, guys. Thank you, everyone.
Okay, and with that, we are going to move on to OBOL Network's presentation. Oshin is similarly going to present the results from Lido's first pilot using OBOL.
Okay, thanks, Izzy. Hey guys, my name is Oshin. I'm one of the co-founders at OBOL, and today I'm going to briefly chat to you about the testing we've been doing with the Lido team for the last month or so. Very briefly, for those that aren't familiar, who is OBOL Labs? OBOL is an R&D team building infrastructure technology for Ethereum. The core team is over 20 members at this point across 10 countries, and we're currently focusing on building distributed validator technology for Ethereum. What is DVT? I won't spend much time on it because I think most people here are familiar, but DVT divides a validator across multiple machines, and this can prevent lots of the kind of common failures that validators come across, like software issues, hardware issues, private key compromise, a big one, and then generally Byzantine behavior, or an operator going rogue, you might say. In terms of OBOL's design decisions with regard to distributed validator technology, we've been particularly focusing on trying to reduce correlation and reduce kind of correlated failures, because as most people here know, the Ethereum protocol is designed to punish centralization of all forms. And DVT, it's very important that we don't increase centralization instead of decreasing it. So some of the things we've prioritized, we don't ever create a validator private key in full anywhere. We've had DKG more or less from the start. So all operators create the private key together. Our validator client sits as a middleware, and it doesn't actually control the private keys nor have the ability to sign. So if the situation did happen that the software was compromised, it wouldn't be able to get anything slashed, assuming that the validator clients beneath it are working as intended. One of the big decisions we made was to have no shared gossip network across independent clusters. This is a few benefits. One of the main ones being faster latency, or lower latency and higher throughput versus a gossip network. That's super important to have a validator that is profitable versus a solo validator, because if, you know, a distributed validator is, you know, way off what a normal validator will make, it becomes very hard to justify. And one of the other things about having independent networking stacks is you are not tied to upgrading software all at once or not at all. You can, you know, roll it out cluster by cluster and ensure that a new upgrade is healthy and stable before you decide to upgrade it across your entire stack. To briefly touch on how the performance went so far, we had 2 clusters as well. This time we did a 4 validator cluster and a 4 operator cluster and a 7 operator cluster. These numbers are important because with 4 operators you can have 1 validator offline, and with 7 operators you can have 2 validators offline while the validator stays online. The operators that took part are all listed here. Thank you guys for taking part. The performance, we're super happy with how things went so far. In particular, as kind of Izzy pointed to, block proposal is probably one of the most difficult kind of tasks of a distributed validator, because there's, you know, the pre-consensus step, as you might mention. So far we're 2 for 2 on block proposals, so we're very happy about that one. And yeah, generally validator effectiveness, I think depending on how you calculate it, 80% or so of validators are offline on Goerli. So that's why the effectiveness is at the kind of rates calculated. And yeah, to talk a little bit about our roadmap, we're kind of, you know, in the phase of starting to look towards mainnet, and we've been kind of outlining it into kind of phases or milestones. We're going to go with a guarded launch to start, mainly to build trust with the software on mainnet at small scales before we kind of really take off the training wheels. So the goal would be to do a guarded launch with liquid staking pools, where we'd run, you know, one or a small number of mainnet distributed validators first to build kind of skin in the game trust in the software. The following step would be an uncapped, unguarded launch, where we would kind of take the training wheels off and say that it's safe for use by the general public. At that point, the hope would be that liquid staking pools would feel comfortable taking the percentage of validators that are operating as DVs up off of kind of, you know, 1 or a handful. Later on, one of the decisions we made is not to have too much editability features. So if you aren't, you know, if you are unhappy with your distributed validator, the safest thing would be to exit it and recreate it. But we do intend to add some kind of in-place operator rotation, validator addition and the likes after the kind of initial or like uncapped launch. And then later in the journey, one of the key things that would be nice to have is it is possible to have a 2 of 3 distributed validator, but that would involve changing a consensus mechanism. So that is kind of one of the other things on our roadmap and goals. So some of the key takeaways we had from this testing program, we got a chance to test some of the technical and some of the kind of product and user experience sides of it. So we did 2 distributed key generation ceremonies, 2.5. We did a second one, but we got a good chance to really test this with kind of real operators and get their feedback on it. One of the technical things we just realized we could do is Karen could monitor its own API to see if the downstream validator clients are healthy. We weren't doing that at the time, and it turns out one of the validators weren't healthy. So we missed about 10 attestations at the very beginning of one of the clusters. This is something that we can now prevent with a bit more smart monitoring. As we've kind of alluded to at the start of this call, these clusters were all run with Gnosis Safe as kind of representing these trench code operators. This as a means for tracking rewards, you know, won't really scale, and I believe there's more to come about that later today, so I won't say much beyond that. And one of the kind of product requests that we've been kind of investigating is some level of kind of opt-in push notification to inform an operator of the cluster status. A lot of people can monitor their own cluster, but we're kind of trying to understand a bit how they can see, you know, how the rest of their cluster is getting on and whether everything is healthy. So we're trying to investigate whether it would make sense to give people kind of push notifications to say they or one of their counterparties are offline. That's more or less everything I wanted to say, but the one thing that we've been, you know, trying to convince people of with distributed validators is this meme that, you know, validators should be run as communities, not individuals. You know, right now validation is super new. It's barely a few years old, but we hope over the kind of coming years and decades, people will kind of come to be familiar with the idea that a validator is not a single entity. It's a group of operators or a group of individuals all coming together to validate. Have some of our links there, but other than that, I'm happy to answer a few questions. Thank you very much, guys.
Thanks, Oshin. If there's any questions from any of the node operators on the call, feel free to jump on. But I'll start with a few that I had. If we go back to the points that you were talking about a little bit in terms of like, what is the evolution from beyond safes, right? Like the trench coat operator model that we were using. How are you guys envisioning apportioning rewards, let's say, based on actual performance or not? Is that something that you think that you might leave to all of the different, like, let's say, users of the OBOL infrastructure to implement separately? Is that something that you might offer like a default methodology for users to consume, but then that they can override that if they want to do it a different way? What kinds of things are you considering in that respect?
Yeah, it's a good question. So we started and we kind of spent a lot of time looking at the idea of, can you objectively measure who's online and who's offline and stuff? And we realized after a while that it's a very subjective thing, particularly because if you want to penalize the person that is slightly late, they might be the person that's a bit more decentralized. They might be running their node on, their own hardware, not in the same data center as everyone else. And they might be kind of unduly penalized if you pick kind of a naive, oh, these 3 people were involved and the 4th guy that was a little slow keeps getting excluded. So we decided, and kind of a lot of the time, not to be too prescriptive about how these would be used. So we would hope that the people that want to deploy distributed validators kind of use their own rating methodology. But we do intend to supply kind of the tools to, base your economics on by being able to allow people to see who's online and offline. So from an off-chain perspective, using your nodes monitoring or your Prometheus, you can see which your peers are online and offline. But giving something, in solidity is not super trivial and has trust assumptions like, are you going to have an oracle? Are you going to have some allegedly honest operator listening to kind of messages and reporting honestly as to who's online and offline? So we decided that for the time being, we would just kind of keep it simple, supply these distributed validators that other operators will use, and then gradually up the kind of sophistication of who's online, who's offline, and like inter-cluster performance. And gradually we would like to be able to make it super easy to add your own economics on top. But yeah, for the near term, we said that there was kind of more pitfalls to it than benefits in terms of kind of canonizing one way to measure who's online and who's offline.
Do you think that there's opportunities for third parties to step in, maybe in the short term, to offer those kinds of like services, if you want to call it that? So I can imagine that providers like Rated Network or Metrica or things like that, whose business model is basically, exposing data around validator performance, could potentially create ingests for the metrics that you guys are exposing via your gossip layer, ingest those, and then come up with aggregated metrics for specific clusters. And then maybe it's up to the clusters themselves, via like some sort of like really, really basic DAO where every cluster is a DAO, or the overarching liquid staking protocols to consume that data and use that at least in the short to medium term until there's an on-chain or a trustless solution to come up with these kinds of like performance ratings, so to speak.
Yeah, absolutely. I think you can hit the nail on the head that looking on-chain at the validator's performance at a cluster level is the kind of near-term goal, and comparing different clusters against one another to identify ones that are kind of underperforming. And then looking like intra-cluster at who's online and offline, it makes most sense to have kind of an off-chain party or oracle or data provider that would ingest the Prometheus metrics or otherwise and decide, oh yeah, this person is online and offline, but you do need to rely on some off-chain oracle to report that data. Right now with a threshold BLS signature, you can't trivially see who took part in that BLS signature. You have to kind of rely on some sort of oracle. And we as OBOL have been very keen to not introduce any trust assumptions like, trusting OBOL to report your like oracle or your operator uptime, for example.
Yeah, makes sense. And in terms of like the next 6 months, what are you most looking forward to in terms of like unlocks that are coming to OBOL Network?
So next 6 months is probably mostly focused on mainnet. I think I can announce we've selected our kind of first auditor and are prepping that at the near term, and that will be kind of most of what the first half of next year looks like. And over the kind of full year, some of the features that we took out of what you might call an MVP, like editability and an overhaul consensus, they'll be more on the kind of R&D phase at the start of next year, while the client hardening and production readiness work is ongoing at the same time.
Thanks. I see a question from the Zoom chat, so I'm going to repeat it out loud. How will OBOL help control or manage DVT participants that are really distributed and not located in one or proximal data centers?
I think that's a super good question. And I think the honest answer is that OBOL can't guarantee anything on a software basis. And that's kind of why we decided not to. I think saying that, you can have totally permissionless distributed validators is kind of, I don't understand how that can happen. If you want to have any idea as to whether or not it's 4 people all side by side or just one person, running 4 nodes and pretending to be independent, having some kind of automated algorithm to select people, you have no guarantee that it isn't someone Sybil attacking its stuff. So we decided to go with what you wouldn't call it permissionless, you call it, like known counterparties. So in OBOL, you prepare a cluster with, counterparties you expect, you list their addresses in the launchpad and you send them a link to take part in a DKG. So you would, as Lido, you would, do these DKGs with known operators. You wouldn't just kind of, hope that you're getting real independent entities and you're not actually just getting someone Sybil attacking the network.
Well, you might hope that. We're working on some really interesting stuff with Nethermind from a research perspective. It's still really, really early. But for those of you that are interested in the more technical side of this, you can check out the phase 1 research post by them on this. Phase 2 of the research is actually going to dive deep into what you're talking about here. Is there a decent way to have a proxy to kind of figure out if people are sibling this mechanism or not? And then what kinds of things can you layer on top of each other to have a reasonable heuristic for when this may be happening or not? Obviously, you'll never catch all of them. But if you can catch enough of them, it's probably enough to substantially defend the network from such an attack.
Absolutely. But as you said, it's heuristics and stochasticity. It's not quite like objective. So we decided that, OBOL should just ship the software and let, the data providers and people do analysis on top and let people form their own clusters and not have one prescribed way to define, independent operators that could be gamed, or, no sooner than you set a measure, a measure that becomes a metric is no longer a good measure.
Yeah, and the corollary to that is, like, once you're public around what kind of countermeasures you have, like, people will design ways around them. So
exactly.
All right, thanks a lot, Oshin.
Cheers. Thank you very much, guys.
Okay, for our next segment, we're gonna have Alexandra G, who's also a contributor at Lido, give us a brief description around the Lido Community Validation Manifesto. So Alexandra, if you can also share your screen.
Hey guys, yeah, but Izzy, maybe you can show my presentation, my slides.
Let me try to find it.
Yeah, okay, so I can start. Hello, everybody. My name is Sasha, and I'm a contributor working for Lido. Today, I'm here to give a quick announcement that a set of Lido DAO contributors created a manifesto to, to serve as a reference point for past, present, and future decision-making regarding Lido's evolving operator set. So we have published the manifesto on the research forum. You can find a link right here on this slide. Yes, thank you, Izzy. So I can also provide it below the YouTube stream. Just a sec. So there we outlined contributors' vision on the main purpose of Lido strategy, our goals for the extension of the Lido operator set, what we have already done in this direction, what we are working on right now, and the next steps toward achieving these goals. Actually, by publishing this post, Lido DAO contributors want to receive feedback regarding these goals. And it is important for us to get opinions right now from node operators, from Lido stakers, LDO holders, and the wider community, because all subsequent decisions in the extension of Lido node operator set will be based on goals outlined in this manifesto. Yeah. So I'm grateful for your feedback, for your comments, any additions and opinions. Please feel free to maintain the discussion on the research forum. And yeah, it seems that's it from my side. Thank you, guys. And I'm waiting for your opinions, feedback on the research forum. Thank you.
Thanks, Alexandra. So I think maybe just to add something from my part as somebody that took part in assembling this manifesto, it's probably a bit less of a manifesto in the sense that there's clear actions described. It's more like a set of principles, kind of similar to what we were talking about when we made a operator set strategy that we suggested for the DAO and the community to embrace. So the idea is to make clear the principles and the ethos that the current Lido contributors operate by, what we identify as being the underlying principles of the network that we operate on, so specifically in this case Ethereum, and the fact that this kind of alignment of values underlies and carries through the way that we are considering design, implementation, and execution of the various strategies, products, and tactics that we employ. And with that in mind, I'm going to pass it off to Eugene, who is a contributor from Lido's protocol team, to give the first public announcement of the Lido staking router proposal.
Yeah, thanks, Izzy. My name is Eugene. I'm Lido protocol developer, and I want to present staking router. It would be technical introduction in staking router, what it is, what's the idea behind our proposal as a dev team, and 1 second, yeah. So, and yeah, it's also a talk to encourage you to provide some feedback to proposal. I also sent to the chat link to ADR. ADR stands for architecture design, architecture decision record. So you can find there all product background why we build this, and what other way we take a look on different ways and decide what actually we want to build. Agenda for today, it's trying to understand where we are now and what is staking router is about. Right now, Lido has a created validator set. It's pretty good and really diverse set, included small operators and client teams. But in the long run, we just want to push to maximum decentralization of our validator set, and all this thoughts summarized in a blog post. I guess that a lot of people already check it out. Yeah, because it's our kind of manifesto for next chapter for the Lido. And we committed to adopt DVT, also permissionless validation, solo staking, and yeah. And we have recent progress. Yeah, on this slide I outlined recent progress. I guess that first 2 items already covered very well with previous speakers. And the last one, it's Nethermind published first part of their research about decentralized identity. And it's really, as Izzy already said, it's pretty intersected with all this question about how to ensure that this is committee, just not single entity, how to resist to Sybil attack, and that direction to create kind of in other direction. It's also create something like node operator score, which would allow to effectively lower bond to join like validator set permission listing. Yeah, from validator set perspective, we have like a lot of direction, so a lot of possible features that we want to incorporate to Lido protocol, and we want to go into all that separate direction in a parallel way. Yeah, but this different direction allow us to build like different features in a Lido core protocol. And like before, like dive deep into the staking culture, let's discover like current architecture and why it's not suitable to go into that parallel direction quickly. Yeah, so yeah, I want to talk about architecture. So yeah, like it will be like black boxes like smart contracts and blue circles as actors. So it will be like that. So this is the current Lido protocol design. You can see like 4 core contracts. It's Lido and stuff. It's token contract and like main controller. The practice registry, which holds a list of validators, distribute rewards, and so on. Oracle, it's a contract that helps Oracle daemons to coordinate and like rebase stuff by then taking into account rewards. And deposit security model, it's a security model which helps to mitigate front-run vulnerability. Also, like Guardian set, like 4 out of 6 Guardians who like completely like continuously observing like deposit contract and not operator registry, sign messages, propagate to depositor bot, which allow to actually deposit and delegate effort to deposit contract that previously submitted by like Lido users. And yeah, also I outlined staking rewards distribution, which starts with the Oracle report, and after that, Lido, like the main contract, means additional stuff to pay rewards to node operators. And why I outlined these 2 processes, because if we imagine like Lido validator set consists of several different systems, for example, like created, it's what currently we have. So we have like validator set created by the DAO. Also, we want to have like community or solo staking, DVT validator subset, probably like different flavors of DVT. And since we want to have all of these working together, we need to change our monolithic approach to building smart contracts, because to incorporate all the stuff in parallel, we need to like apply different changes in different parts of protocol, which would be tricky. So that's why we propose to build a staking culture. Like in a nutshell, staking culture, it's very similar to node operator registry. Instead of node operators, we would have like staking models, which actually is smart contracts that can help arbitrary logic about how to form validator set, what is the distribution reward rules, how to enter and exit, and so on. So yeah, each model would hold like a list of node operators. And by node operators, I mean like this particular data structure. So like some human readable name, reward address, amount of active validators, stopped or withdrawn validators, and ready to deposit signing keys. Separation of concern between staking crawler and models would be like staking crawlers. It's like router and controller, and it maintains a list of staking models, distributed stake and reward between them. work with deposit security models and able to parse and parse each model to mitigate vulnerability, make a deposit contracts with key fetched from the models. And staking models responsibility, it's actually maintain, like each model maintain a list of node operators, has its own rules to enter, exit, validator set. Each node operator can be a committee, whatever. Yeah, so it's just staking model can decide how like this particular validator subset would be built and managed. Another thing is how to distribute stake between node operators, how to distribute rewards, manage signing keys in a way like right now, our created set manage keys in a way just store it on chain. That's pretty expensive. It can be optimized by pushing these keys to off-chain or L2. And also each model can have its own fee structure. So model could define which fee it just reserved for node operators, and also in a staking culture, we designed to mind that treasury fee can be also stated independently for different models. And yeah, the most interesting things in this proposal is like staking balancing algorithm. Like the main difference from current staking balancing algorithm is that we want to define desired share of each validator subset and staking model. And there is a fallback model. Like what is the purpose of fallback model is aggregation all stacks that can be accommodated by other model. For example, because of lack of the keys that ready deposit. Why it might be happens? Because, for example, if there is a model like permissionless with like 16 effort bond, and in the same time, it's like big demand on staking, it might be the situation that it's not enough validators that are ready to put 16 effort bond, and we need to push all the stake to, for example, create a model that is effectively unlimited capacity. So yeah, that's the reason why we need fallback model. And yeah, here is example. Like important disclaimers that final percent might be defined only by the DAO. This is just examples only. So we have like staking model A and B with target share 10 and 20%, with some like examples, current share and active validators and ready deposit key. And imagine we have situations that we have like big amount of effort in buffer, and after run like 10,000 validators. And we want to distribute this new effort among models. So as we did in the previous algorithm, for node operators, we can start with smallest and try to put a stake there. We can see that we can use all ready to deposit keys for these models, but for staking model B, we cannot do this because we have target share, and we cannot use all 5,000 keys. Yeah, we can see like math on the bottom that how we know this, because we just add all validators that we have like over like all active validators, and like all new validators, calculate share. So we have like maximum 22,000 validators, do some like math, and okay, we can onboard only like 4,000 validators here. So we still have like 1,000 validators that we need to distribute to some model, and we go to a fallback model, and like new allocation table would be might look like this after the allocation will be finished. So the main idea, so like once again, like the main idea that algorithm taking account two main things. It's like keys that models ready to deposit immediately, and a target share, target and current share that like target share, that's what is the ideal proportion it's set by DAO would look like, and the current share, it's like current proportion. And yeah, also want to talk about how deposit process would look like with the staking approach. So as we've seen before, we also have like depositor bot, but now we can have like separate depositor bot for separate staking models, and staking approacher would coordinate this. So on like each time when like Lido core protocol decided to stake some amount of effort, it just send it to staking approacher. Staking approacher have like this allocation table, how much effort depositable by, like in this case, created model and other staking model, and like depositor bot could just observe this table, and if like some effort is available to deposit, just run the transaction and deposit will happen. And reward distribution also would go through staking approacher. So on an Oracle rebase means additional shares, additional stuff sent to the staking approacher, and staking approacher just handle reward distribution. So in our first iteration, we just thinking that reward distribution should be the same like we have on the operators. So not based on performance, but based on proportion of how much validators under each model control. Yeah, but models could distribute rewards in any way. So like performance based and like any way which models like. Yeah, so like this proposal contain only like some like basic things about staking approaches, and a lot of features are missed right now. And we think about that we want to put these features in our next iteration. The most important feature is operating with bonds. Right now, Lido protocol is not supported bonds as a first-class citizens, but it can be bypassed by wrap bonds to the staked effort. Stake balancing right now would be only for staking, but only like the missing part is like in the future we need to create a mechanism to balance stake not only by staking but only with withdrawals. But now it's out of scope because after staking approacher would be deployed, it would be like only like one model that actually like created model that it's not a registry right now. Also, we want to think about how to make cost on case storage and uploading cheaper by incorporating off-chain or L2. And yeah, also like performance-based reward socialization, maybe like it's worth to, like if, for example, we have like different staking models with different like performance, maybe it would be fair to build some performance-based distribution of rewards. But it's also like only a proposal or just trying to outline like future directions. It's not that we currently have some statement or just it's not outlined in the proposal. And the current proposed staking approach architecture unlocks ability to build models like DVT, like different flavors or solo staking. It's so it's very important to start build and experiment on different approach to diversifying Lido validator subset. And timelines that dev team have in mind that we want to have like next big upgrade in March. So like right before Shanghai Capella hard fork, and incorporate withdrawals and staking approacher to this upgrade and deploy this to the mainnet. Node operators registry would be created model. And after that, like we really looking for a team and really looking for idea to build staking models. I guess that it would take some time. Like in case of my perspective, it's something like it would be good to have something in production till the end of 2023, because it would be also like testnet stage, and also we probably will need to upgrade staking router on version 2 to incorporate like next model. Yeah, that's it. Thank you, and I'll be happy to answer on your questions if you have any, or we out of time. Easy.
No, we can keep going for sure, because I think people will probably have questions around this. I think there's already a few.
Okay, yeah, let's stay and discuss.
I see that there's a question asked in Zoom. Do you want to ask it on stream, or would you prefer that I just repeat it for you?
Let me see. It's a question how Lido will decide what proportion to be used for each staking model. Yeah, it's a good question. I think that Lido DAO could like, if we have, for example, like several interesting or like models like solo staking or like DVT, we can start with like small numbers. Yeah, it's like my proposal to start with small numbers to like deploy this model to mainnet and start under reasonable caps, and after that gradually increase share of these models to push decentralization of our validator set. But it's definitely a governance decision. Should be some like risk management and so on. Thank you for the questions. And if you have any other question, please ask or send to the chat.
So I have a couple of questions. So in terms of like the development of different modules, how do you envision like the different ways that might happen? Would they all be developed internally? Would they be developed externally and then like reviewed by Lido contributors and audited, or do you think that there might be a mix? How do you see this working?
I really want to onboard like more teams that want to build to encourage the external teams to build models for Lido. It would be very nice to have like another teams, and it would definitely require audit external, and it would definitely require some a review from internal team. We also would be happy to collaborate on specs, and since it's taking router, it's very early. We really would be happy to start talk about like if someone have an idea how like about building model, we're ready to like start conversation as early as possible to see what's missing feature in a protocol core, what else required maybe to be upgraded and so on. So we really want to collaborate on this, but like prefer to have like external contributors here.
Looks like we have a question from the YouTube stream. So currently node operators are in charge of signing the exit messages for staker withdrawals. How will we prevent the threat of potentially bad nodes refusing to sign exit messages?
It's actually good questions. I think that we really like right now we preparing like EAP about like smart contract triggerable withdrawals. So and we think that running fully permissionless models would require these improvements to Ethereum. We're going to publish this EAP soon, and after that, this EAP would be landed. It would be like absolutely safe to run fully permissionless models. And in case of node operators of that permissionless model would refuse to withdraw, Lido DAO would have like smart contract handle that force eject this particular validator in a forced way. And yeah, I think that end game is like that. And short term would be, for example, if we have in mind like DVT model, we can build a committee out of like created validator, mix it with permissionless. And in this case, like if we have like majority of created validators, we can just ask them to eject, and it would be the same assumption that we have right now with created set about exiting keys. So we can experimenting with this like semi-permissionless approach and go permissionless on a wide scale after we have like fully permissionless way to exit validators.
And it looks like I don't see any other questions either in the chat or on the public stream. So maybe if we can just close out with like what are the immediate next steps with regards to the staking router and withdrawals, Eugene?
Okay, immediate step is just we published ADR. We're looking for feedback, and right now we're in the process of like development, but still like we can just incorporate some fixes into our design, and we're planning to release it with withdrawals in end of March, maybe in the beginning of April. It depends on final date of the hard fork. And in the meantime, we can start talk about building models that would be plugged into staking router this year, like next year.
Okay, thanks a lot. We're gonna stick around for a couple more minutes just in case anybody has any more questions, either from the stream or on the Zoom call. But if not, we're gonna wrap up the second community call. A recording or at least like a packaged video version of this will also be available at a later time. And we hope to have the next community call in the end of January. So sometime between the 20th to the 26th of January. Thanks everybody for tuning in. And hopefully see you in next month's call as well.
Thanks, guys.
Thanks.